In this video, we will learn about the principle of a vernier. So in a vernier, each division on a vernier scale V is slightly smaller in size than the smallest division on the main scale M. In a common form, generally n vernier scale divisions coincide with n minus 1 main scale divisions. Okay, or I can say one vernier scale division is equal to n minus 1 divided by n main scale divisions. Okay. Now, one main scale division minus one vernier scale division would be equal to one main scale division minus 1 into n minus 1 divided by n main scale division. That would be equal to 1 upon n main scale division. Now, the difference between the values of one main scale division and one vernier scale division is known as Vernier constant of a given vernier. It is the smallest distance which can be precisely measured with the vernier scale. Therefore, it is also known as the least count of a given vernier. Now, what is a Vernier constant? It is one main scale division minus one vernier scale division, that is equal to 1 upon n main scale division. You can also write it as the smallest division on the main scale divided by the total number of division on the vernier scale. Let's take a simple example. In a commonly used vernier caliper, one small main scale division reads 1 mm and 10 vernier scale divisions just coincide with 9 main scale divisions. Now the vernier constant will be the smallest value on the main scale, that is 1 mm, and total number of vernier scale divisions, that are 10. That would be equal to 0.01 centimeters. Now how will you read the vernier calipers? Now the reading through the vernier calipers. So the object whose length or the thickness or diameter is to be determined is inserted between the jaws AB. Now the sliding jaw B is adjusted till the object is held between the two jaw. The sliding jaw is fixed in this position by the screw S. The screw S. Now note down the reading on the main scale division just before the zero mark of the vernier. Let the zero of the vernier scale lie between 5.5 and 5.6 centimeter on the main scale as shown in this particular figure. This is 5.5, this is 5.6, and the 0 is between 5.5 and 5.6. The main scale reading to the left of the 0 of the vernier scale is 5.5, that is this part. Now see which division of the vernier scale is exactly coinciding with the main scale division. In the figure, the fourth division of the vernier scale exactly coincide with the division on the main scale. As you can see in this particular picture, the fourth division, that is 1, 2, 3, 4. So this fourth division is exactly coinciding with the division on the main scale. It means the distance by which the zero of the vernier scale has advanced ahead of 5.5 centimeter. That is 4 into vernier constant. That is 4 into 0.01 centimeter. That would be equal to 0.04 centimeter. So the length of the given object will be 5.5 centimeter plus 0.04 centimeter. That would be equal to 5.54 centimeter. Now the total reading would be given by this formula where capital N, which is the main scale reading just before the zero mark on the vernier scale, here which was 5.5, plus small n, that is number of vernier division which coincide with any of the main scale division, which is here was this fourth one. N plus small n into vernier constant will give us the total reading. An important point to be noted here is that the main scale reading with which the vernier scale division coincide has no relevance to the reading. Okay, it is just for this small n value. Now the zero error or zero correction. So in a correctly adjusted vernier caliper, the zero of a vernier scale exactly coincide with the zero of the main scale when the movable jaw B is just brought in contact with fixed jaw A. However, in some instruments, the zero of the vernier scale may not coincide with the zero mark on the main scale. In such cases, the instrument is said to possess zero error, which may either be positive or negative. So what is a positive zero error? If the zero of the vernier scale lies to the right of the zero of the main scale, like this is the zero of the main scale and this is the zero of the vernier scale. Now, this zero error is positive. If x division of a vernier scale coincide with the main scale division, then positive zero error would be represented by plus x into vernier constant. Now in the figure, as you can see, the fifth division of the Vernier scale exactly coincide with the main scale divisions. So the positive zero error would be plus 5 into Vernier constant. Okay. If the Vernier constant here is 0.01 centimeter, then it would be 0.05 centimeter. Positive error. Okay. Negative zero error. So if the zero of the Vernier scale lies to the left of the zero of the main scale, like this, then the negative zero error is there. Now, if x the division of the Vernier scale coincide with the main scale division, then the negative zero error would be 10 minus x into Vernier constant. In figure B, as you can see, if you clearly see in figure B, you see the zero error of the Vernier scale lies to the left of the zero of the main scale division, and the fifth division on the Vernier scale perfectly coincide with the main scale division. Then the zero error here would be minus 10 minus 5 into Vernier constant. If Vernier constant is 0.01 centimeters, then the answer we will get is 0.05 centimeter with a negative sign, that is negative zero error. Now the zero error is always algebraically subtracted from the measured length so as to get the correct length. Third is zero correction. Zero correction has a magnitude equal to zero error, but its sign is opposite to that of the zero error. Zero correction is always algebraically added to the measured length. Thus, the corrected length would be measured length minus zero error with sign. Or I can say the corrected length would be measured length plus zero correction with its sign. So if it is zero error, we will subtract it from the measured length. But if it is the zero correction, we will add it with the sign. Okay. I hope this topic is clear to you. Thank you.